Hello and welcome to another video. Today we're going to look at the enzyme kinetics, the derivation of the Machealis-Menten's equation, that is the biochemistry. So now, first of all, since we are on the new year 2024, I wanted to share these words to you, even though that life can throw challenges to you, pero Ricardo estoy para atrás, no te rindas. That is a Spanish-speaking person, and I'll be here to make sure that we go through everything that will help you to overcome those challenges. So today, anyway, let's get into it. So we have here the E plus S. That means that the E stands for the enzyme and S stands for the substrate. And then we have that equilibrium there, and then we get ES, that is an enzyme substrate. And then you have a K2, and then we produce an enzyme and a product over there. So now, in order to derive this equation, we have to first look at the steady state assumption. This assumption helps us to derive this equation. So it's a state assumption. So it's a steady state assumption, and then the steady state assumption states that so now let me write it down. A rate of formation of ES is equals to the rate of breakdown of ES. And then that is the steady state assumption. It states that the rate of formation of ES, that is the ES that we're talking about, the enzyme substrate, is equals to the rate of the breakdown of that ES. So now let's find out which one forms the ES. And then in this equation over here, E plus S, and then we have that K1 over there. It forms the what? The enzyme substrate over here. And then let's take it at the rate of formation of ES. And then we say K1 is K1 into the concentration of the enzyme, and then the concentration of the substrate over here, because this one is the one that is going forward and makes that ES over there. And then we have is equals to the rate of the breakdown of ES. We have ES over here. Looking at this reaction over here, ES is broken down into an enzyme plus a product over there. So let's take it and say K2 here, and then we'll say the enzyme substrate, and then plus, because there is this reaction over here that in this equilibrium over here, we have an enzyme substrate as a product, and then it forms, it goes under the reverse reaction, and it forms the enzyme substrate over there. And then we have a K1, K negative 1, and then we have the enzyme substrate over here. And then now, what you can just look at is the rate of formation of rate of change of ES. The rate of change of ES, we can just say it's a D ES enzyme substrate over dt, and then is equals to the K1 over there, and then the concentration of E, and then the concentration of S, that is minus the K2, and then the concentration of ES, and then minus the K of negative 1 times the concentration of ES, that is equals to 0 over here. So now what we can just do now is to since we can see that here we have a a concentration of ES and then a concentration of ES, it can give us it can give us the common factor over here, and then let's deal out with that common factor, and let's say now concentration of E over here, and then concentration of S, and then minus we take out the common factor in this type of in these terms over over here, and then we say a concentration of ES, and then we say over here now we have the K of a -2, and then we have since we took out the negative sign over here, we will say over here plus, because a negative times a positive, it can give us a negative over there, and then we say a plus a -1, and then we close the brackets, and then we say is equals to 0 over here. So now what you can just do is to transpose this this term over here into the over this side, and then we say a K1 into concentration of enzyme, and then of a substrate, and then is equals to a concentration of ES is equals to the concentration of ES over here, and then K2 plus K -1, and then we close those brackets. And what you can just do now, we can just try to find the concentration of ES and make it the subject of the formula by dividing everything over here by K2 plus a K of -1, and then even this side we say K2 plus K -1. And then now what you end up having is the concentration of ES that is equals to a K1 over there, and then a concentration of E, and then a concentration of S, and then over now a concentration of K -1 plus a K of +2, and then we close those brackets. And now something that I should introduce now is a Machealis constant, that is a Km. And then let's look at the Machealis constant quickly. So now the Machealis constant, since we have the concentration over here over ES, that is equals to K1 into the concentration of E, and then a concentration of S, and then over the K of -1 plus a K of +2. And then now what you introduce over here is a Machealis constant, that is a Km, that is equals to a K of -1 plus a K of 2, and then over a K of +1. So that is a Machealis constant. And now what we can just do, we can just try to find the K of +1 over here, and then say K of M times a K of +1 is equals to a K of -1 plus a K of +2. What we just did over here is to cross multiply everything, and then I say the K of +1 with a K of M over there, as you can see. And then what you can just do is to divide with the K of the Machealis constant, that is Km, in both sides, so that you can have a K of +1 on that side only, and then now we end up having the K of -1 plus a K of +2, and then over a K of M. And then now, since we have this over there, that is a concentration of ES, that is equals to K1 concentration of E. What you can just do over there is to try and introduce, in place of a K of +1 over there, we replace it with a K of -1 plus a K of 2, and then over the K of Km. And then now what you can just do is to say concentration of ES is equals to, in place of a Km, K of 1 here, since we have a K of 1 there, we can just say a K of -1 plus a K of 2, and then over a Km, and then we multiply it with a concentration of E, and then a concentration of S over here. And then now what you can just do, since we have that that over a -1, k of -1 plus a k of 2. Let's not forget that one. And then now let's try to find, simplify this one. Concentration of ES is equals to, and then now what we can just do is to say a k of -1 plus a k of 2 over km, and then concentration of E, and then a concentration of S multiplied by 1 over, because we are trying to remove this division over here, and then we'll take that one that is on the denominator, and we say 1 over k of -1 plus a k of 2. And then now what I just noticed over here is that this one is similar to that one. Since we have only the multiplication over here, we are allowed to cross out this one. And then now what we are left with is the concentration of E over here, and then a concentration of S, and then this one times a 1, it's as simple as a concentration of E and a concentration of S over now. We have a 1, we're left with a 1 over here, a km times a 1, we're left with a km only. So now that's and now what you can just do is to introduce something else, that is a enzyme total. So the enzyme total, it says we have the enzyme total, ET is equals to E naught. They say ET is equals to E naught, that is equals to enzyme plus an enzyme substrate. I hope we see that. So now let's introduce the concentrations now instead of the enzyme E naught only. Let's say E naught, concentration of E naught is equals to the concentration of E, and then plus the concentration of ES, because we are working with the concentrations over there. So now let's do the same to that. So now let's try to find the concentration of E only. Let's make the concentration of E the subject of the formula by transposing the concentration of ES to the other side, and then we're left with the concentration of E that is equals to the concentration of E naught minus the concentration of ES. And then now what you can just do, hope you see that, what you can just do now is to take this, since we have this one over here, the concentration of ES, you see over here we have the concentration of ES, that is the concentration is equal to the concentration of enzyme and the concentration of substrate over the concentration of over the Km. What you can just do over there now is to, let me write over here, what you can just do over there is to try and substitute the concentration of E. So now we have the concentration of ES that is equals to, in place of an E over here, or maybe let me firstly write it and then say a concentration of E and then a concentration of S over the Km. And then now we say over here we have the concentration of E as this one. So now let's replace the concentration of E with this now. So we say E naught and then minus the concentration of ES. And then now let's not forget that we have the concentration of what? Of S over here. Then let's say over a Km. So now since we have the concentration of ES as this one, let's try to make a E naught now the subject of the formula, but not a what? Not a ES. Let's try to make an E naught that one. So what you just what we can just do over here now, we can just maybe let me use another one. So now we said we have this one, this as a concentration of ES that is equals to the concentration of E naught minus the concentration of ES, and then with the concentration of S, and then over the Km over here. And then now what you can just do is to make that E naught the subject of the formula, this one, and then let's say now the concentration, or maybe let me say first of all that this one we cross multiply over here, 1 times this one, we'll have this one 1 times this over here, this is a numerator, we have the concentration of E naught, and then minus the concentration of ES, and then we have the concentration of S, and then that is equals to now this one times this denominator over here, we end up having the concentration of ES, and then multiplied by the Km over there. So now what you can just do is to remove this concentration of S with the division. So let's say the concentration of S over here, and then the concentration of S over here. And then now we are left with the concentration of E naught, that is equals to, that is minus to the concentration of ES, and then that is equals to now the concentration of ES times the Km over the concentration of the substrate over there. So now it's easier for us now to transpose this one by adding this in this side and that side. So now we'll end up having the concentration of E naught, and then we have the concentration of ES, and then times the Km value, the Km constant, I mean, and then we say the concentration of S, and then times the plus, and now plus because it was a negative of that over that side, and then now it becomes the positive on this side. That is the concentration of ES. So now if you can just take a look over here, what we have now, we have the concentration of ES in this term, and then we have the concentration of ES over that term. So it means that we can just take a common factor, that is a concentration of ES, and then we say, and now since we took the concentration of ES, we are left with the Km over the concentration of substrate, plus now over here we took the concentration of ES as a common factor, so now we are left with the 1. So now what you can just do over here now is to make sure that we are left with a concentration of ES only on this side, and then let's do so by dividing over by a Km over the concentration of a substrate plus a 1, and then now we are having over here also this side the Km over the concentration of a substrate plus a 1 over here. And then now what you can just do, since this one cancel over this one, and then we are left with the concentration of a enzyme substrate ES over here, and then that is equals to the concentration of E naught over the Km over the concentration of substrate plus a 1. And then now what you can just do, because we are dealing with the mathematics, something like that, this means that we can just do the mathematics gymnastics by taking that concentration of E naught and then put it on the side, and then we say 1 over here and over a Km over the enzyme, the concentration of S plus a 1, and then we close those brackets. This thing is also the same as this one. It's just that when we want to go back and into that one, we can just say the concentration of E naught times a 1. It can give us that a concentration of E naught. Yeah. So now we need to introduce one more thing. It's one last thing now that we need to introduce. Since we got that concentration of ES, is equals to the concentration of a E naught into the brackets, that is a 1 over the Km over the concentration of a S plus a 1, then close those brackets. And now let's take a look at on the reaction. We have a E plus a S, and then the equilibrium, a K1, and then a K of a -1, and then a ES, and then the enzyme plus a product over here. So here we have a K2. So now what we need to introduce over here is it's a rate of formation of a product. We are talking about this product over here. So it means that we look at the reaction that starts from the ES up until to the product. So now for the rate of the formation of the product, so we need to find the rate of the formation of a product. Since we can see that this one, the ES is the reactant, so it has a rate constant that is a K2, and then it forms the here the enzyme plus a product. So it means that the rate of formation of the product, and then it will be now the rate of formation of the product will be equals to that K2 over there, that is the rate constant, and then now the concentration of the ES. So here we have this one as the rate of formation of the product. This is the one thing that we needed to introduce so that we can finally get the answer for the derivation of the Machealis-Menten. So now we know that the concentration of ES is also equals to that one over there. You can see that one, the E naught that is into 1 over Km, the concentration of S plus a 1, then close those brackets. So it means that if we have this ES over here, we can replace it with that thing because they are equal. Here is the ES, as you can see over here also, it's a ES that is equals to the E naught, concentration of E naught into 1 over Km divided by the concentration of S plus 1, and then close those brackets. And then now what you can just do over here is to replace that concentration of ES with that thing over there. So it's equals to the K2 and then the concentration of E naught, and then the brackets 1 over the Km over the concentration of S plus a 1, and then close those brackets. So now you can see that we got this now. And now what I need to just remind you or to say over here, once we are here, we can see that we have this one is the rate of formation of the product that is equals to the K2, that is concentration of E naught, and then into 1 over the Km over the concentration of S plus a 1, and then close those brackets. And then now what I need to just tell you that is that the rate is also equals to the velocity. So now what you can just say, I will discuss with you that in the next video, discuss it deeper. But what I can just say to you now is that the rate is also equals to the what? To the velocity. So it means that here we can just in place of a rate, we can just put the velocity. So we said a rate is equals to a velocity in this chapter. So take note of that. So the rate is equals to the velocity. It means that in place of that that rate of formation of the product, we can just put a v that is equals to, now we say is equals to the K2, and then the concentration of E naught, and then 1 over the Km concentration of S plus 1, and then we close those brackets, and then now we can see that we have two division signs over here. So now what we can just do is to do some mathematics things over here, just to remove this concentration of a S over here, and then to simply make things easier for us by just saying over here multiply by the concentration of a S. We'll say over here the concentration of a S, and then now what you end up having is the K2, and then a concentration of a E naught, and then now one times that concentration of a S over there. Open the bracket, we get the concentration of a S, and then over now that concentration of, or then we say Km over the concentration of a S times that concentration of a S, and then they end up cancelling each other, and then now we are left with a Km, and then now we say plus over here, and then we say 1 times that concentration of a S over there. We get a what? We get the concentration of a S in this place, and then we close the brackets. And then now, what I need to just tell you also in this Machealis-Menten's equation is that we have a Vmax. The Vmax is it's whereby the enzyme active site is saturated with the substrate. So do you remember when I said that E naught is equals to ET? That means that it's a total enzyme. So it means that if we have the total enzyme, definitely we have the enzyme active site being saturated with the substrate. So it means that in this place over here, we can just put a Vmax because this E naught here is equals to the ET. The ET is a total enzyme. When we have the total enzyme, it means that we have the what? The enzyme active sites being saturated with the what? With the being saturated with the substrate. So it means that now what you can just do over here is to just replace this thing, the K2 times the E naught over there with a Vmax. And then now we'll say concentration of a substrate over the Km plus the concentration of a substrate, and then close the brackets. So now what you can just do is to write it a little bit neat over here and say V. Don't forget that we say the rate is equals to the V over here. So now V is equals to now Vmax, and then into the brackets we have the concentration of a S, and then over the Km plus the concentration of a S over here. Finally, this is the Machealis-Menten's derivation equation. So now this is it. Let me highlight it with a different highlighter. So this is it. Good people, and I thank you for watching up until this time. And if you were watching up until this time, please don't forget to do those nice things, to share the video, to subscribe, like the video, or you may comment down in the comment section just to make me reach more people. By doing those things, you guys help me to reach more views. So thank you for watching. Muchas gracias for watching the video. So yeah, we will meet in the next video. But until, please guys, do take care.